Okay, let's jump right in. Today's deep dive is, well, it's into maybe the most complex thing we know, the human mind. Specifically, we're taking a bit of a shortcut, looking at the psychological foundations underpinning modern psychiatry. We're drawing on some really comprehensive textbook sources that map out how we sense, perceive, and, ultimately think. Our goal here really is to give you a framework, a way to understand that link between biology and behavior. We want to unpack how biological, psychological, and social forces all work together synergistically to, well, build your brain. And importantly, explore how disruptions in those core cognitive functions can actually lead to psychopathology.
Right. And I think what's essential to get right off of that is this foundational idea, that old split between nature versus nurture. It basically just vanishes here. Your brain isn't just some passive biological machine waiting for input. It's fundamentally a social organ of adaptation. It's built through interaction. Experience doesn't just happen to the brain. It actively rewrites it. It shapes your neural circuits. And maybe most profoundly, it influences epigenetic regulators. These are the systems that control which genes get turned on or off when, how strongly, all based on your environment and the experiences you have.
That reframing is huge, isn't it? The old model, it kind of saw the mind as this simple input-output thing, almost like a computer program running linearly, which brings us to that distinction that used to dominate psychology, hot versus cold cognition. So what was wrong with thinking about cold cognition?
Well, the assumption was that you could study complex stuff like reasoning, problem solving, as if it were totally separate from emotion, purely logical. That was the myth of cold cognition. But what modern neuroscience shows, pretty definitively, is that the neural networks for perception, thinking, memory, they're all tangled up. They're interwoven with the networks processing emotional value, your body's state, survival priorities, meaning.
So emotion isn't a distraction from clear thinking. It's actually part of it, required for it.
Exactly. I mean, sure, some cognition is relatively cool, like stacking dishes or adding simple numbers, but context changes everything. That same math problem becomes intensely hot, emotionally charged. If failing means you lose your job or you're embarrassed in front of people, the mind emerges from this integrated reality of brain, body, and the social world around you. Emotion isn't some side effect. It's described as a profoundly integrative process. It literally connects your body to your brain, and it links people together socially.
Okay, so let's walk through how that emotional value gets assigned. Our sources mention like 3 quick stages. It starts with a basic alarm.
Right. Stage 1 is the arousal appraisal system. That's the brain basically yelling, hey, this is important, pay attention. It flags significance. Stage 2 is the hedonic tone appraisal. This is the quick sort, good or bad, approach or avoid. It directs the flow of energy where you focus.
And only then, after those super quick appraisals, does the brain kind of elaborate it into something specific we recognize, like joy or fear or anger. These categories that seem universal across cultures.
Precisely. And this really rapid embodied appraisal,
Yeah.
that's where intuition often comes from, the gut feeling. Which brings us neatly to Antonio Damasio's concept of somatic markers. These are bodily responses, heart racing, stomach tightening, that provide immediate sort of gut reaction input into your cognitive processing.
So the body's actually sending signals back to the brain about choices, maybe even before we consciously reason them out.
Absolutely. The key brain region processing these somatic markers is the ventromedial prefrontal cortex. And what's critical is its connection to the anterior insular cortex, the AIC. This part of the brain handles interoception. That's your awareness of your body's internal state, your heartbeat, breath, gut feelings. Being tuned into those physical cues accurately is absolutely essential for good emotional regulation. If those circuits aren't working well, you're much more likely to run into dysfunctional mental states.
Okay, shifting gears slightly from emotion, let's talk mechanics. We often hear that phrase, neurons that fire together, wire together. How does that actually happen? How does it translate into learning and storing stuff?
Yeah, that phrase captures the essence of Hebbian learning and long-term potentiation. Basically, learning or brain plasticity shows up physically in about 4 main ways. You can have the growth of completely new neurons, the expansion of existing neurons, like growing more dendrite branches, changes in how strongly neurons are connected, and circling back to where we started, changes in that epigenetic regulation we mentioned.
Right. So to really understand how those physical changes store information, we need to get this distinction between the 2 main memory systems that psychiatry talks about. Let's start with the one we usually think of as memory.
Sure. That would be explicit or declarative memory. This is the stuff that requires conscious awareness and attention to actually encode. It heavily involves the hippocampus. This system holds your personal history, your autobiography, and also factual knowledge, like knowing the capital of France. A really key point is that the autobiographical part, remembering yourself and specific past events, doesn't really come online fully until maybe age 2 or 3, as the hippocampus matures.
And the other system, the more unconscious one, that's active much earlier, you said.
Yes, that's implicit or non-declarative memory. This operates completely without any subjective feeling of recalling the past. It's behind your procedural skills, knowing how to ride a bike or type without thinking about it. It also covers learned emotional responses. And because it involves older brain structures like the basal ganglia and the amygdala, it's present right from birth.
And this split between explicit and implicit memory, it has massive clinical implications, right?
Yeah.
Especially with trauma.
Huge implications, exactly. So think about someone experiencing overwhelming trauma. The extreme arousal, the flood of stress hormones like cortisol, can actually cause the hippocampus to temporarily sort of shut down its encoding function. This seriously impairs the explicit memory formation for the event. But the event is still processed, just implicitly, by those other systems like the amygdala. So the result can be that the patient experiences these powerful implicit memory fragments, like a sudden startle response, intrusive images, intense physical sensations, hyperarousal, but without the conscious subjective feeling that they are remembering anything from the past. There's this disconnect, this dissociation between the memory feeling and the explicit memory content.
Wow. Okay, that makes a lot of sense. So memory stores the data, but the brain isn't just a hard drive. It needs organization, right? Interpretation rules.
Right.
This is where mental models and schemata fit in. These are like implicit filters based on past experience.
Exactly. Schemata are incredibly powerful. They're like these highly organized, usually unconscious top-down structures built from everything you've experienced. They act as a lens, biasing how you interpret everything happening now and guiding your behavior. Take Aaron Beck's theory of depression. It's built on the idea of negative self-schemata. If your core implicit belief is I am fundamentally flawed or I am worthless, that schema constantly primes negative thoughts. It makes you selectively remember negative past events, and it twists your interpretation of current, even neutral events to fit that negative view. It becomes this self-fulfilling prophecy, a feedback loop.
And these schematas don't just affect how we see ourselves, but also how we relate to others. Yeah.
Absolutely. Bowlby and Ainsworth talked about internal working models. These are basically relationship schemata formed from your very early attachment experiences with caregivers. Maladaptive schemata, like you see in some personality disorders, that intense cycle of idealizing someone and devaluing them, can be seen as extreme versions or derivatives of these early conflicted relationship models.
Okay, one last piece before we apply this to specific disorders. Let's just quickly define conscious awareness. Simply the subjective sense of knowing, and maybe touch on language, how language itself acts like a big filter, shaping perception, even how diagnostic labels might filter a clinician's view.
Yeah, consciousness is essentially that subjective feeling of knowing what's happening, being aware. Dysfunctions there lead to things like derealization or depersonalization or even hallucinations. And language, yes, it's a massive top-down influence. The words we have shape how we carve up reality, how we think. And definitely, psychiatric diagnostic categories, while necessary, can sometimes inadvertently filter how a clinician perceives a patient, potentially obscuring the nuances of their individual experience by fitting them into a predefined box. Okay, so now let's take these core concepts, attention, memory system, schemata, and see how breakdowns or biases in them show up in specific psychiatric disorders. Start with attention. Remember, it's like a limited pool of resources. Your arousal level is key. If you're under-aroused, too relaxed, you don't allocate enough attention. If you're over-aroused, like highly anxious, you allocate too much maybe, but you lose the ability to discriminate what's truly important from noise.
Right. And moving to schizophrenia, it's so important to understand that the cognitive issues, things like executive dysfunction, problems with planning, and especially impaired social cognition, are just as central to the illness as the more commonly known positive symptoms like hallucinations or delusions.
Absolutely. One key deficit is something called impaired sensor motor gating. You can think of it as a faulty filter. They have a much reduced ability to tune out irrelevant sensory information sites, sounds, internal sensations. Their brain is just flooded, inundated with stimuli that most people would automatically filter out.
That sounds incredibly overwhelming, like trying to process everything all at once all the time.
It must be exhausting. And we see evidence for this objectively. Tests like the continuous performance test, which measure sustained attention, consistently show hypoactivation, meaning lower than normal metabolic activity, in the prefrontal cortex of individuals with schizophrenia. This aligns perfectly with the observed difficulties in executive functions like planning and focus.
And what about their social interactions? How does cognition play into that?
Well, their social cognition is often significantly atypical. Brain imaging studies, for instance, show unusual amygdala activation patterns. It might be hyperactive when they look at neutral faces, so they might misinterpret a neutral expression as hostile or threatening. But conversely, it can be hyperactive when looking at genuinely fearful faces, potentially leading them to miss important social cues about danger or distress in others.
Okay. Now, in anxiety disorders, that attention bias we talked about really kicks into high gear, doesn't it?
Oh, absolutely. It's an automatic attention bias towards the threat. Anxious individuals are basically primed to detect danger. You can see this in tasks like dichotic listening, where they're told to focus on audio input in one ear and ignore the other. Even when supposedly ignoring one channel, if threat-related words are presented quietly in that unintended ear, they show physiological responses or processing interference. Their attention system is automatically scanning for danger cues, even unconsciously.
And for depression, we see those negative schemata creating that vicious cycle you mentioned earlier.
Exactly. The schema theory and network theory of memory really work hand in glove here. The underlying negative self-schemata prime the whole system for negativity. Then, the depressed mood itself acts as a powerful internal context cue. This leads to state-dependent learning or recall. So when you're feeling depressed, your brain automatically finds it easier to access other memories that were originally encoded when you were also depressed. It just reinforces and locks you into that negative state.
We touched on trauma and PTSD already, but just to underline it, the intense arousal messes with explicit memory encoding via the hippocampus. So the memory gets stored implicitly, leading to those body reactions and flashbacks without the conscious feeling of remembering.
Precisely. The explicit narrative memory might be fragmented or missing, but the implicit emotional and somatic memory is deeply encoded. That's why the body remembers, with startle responses or intrusive images, even when the conscious mind doesn't have a coherent story of the past event. And finally, let's look at social phobia, or social anxiety disorder. Here, the cognitive distortions are laser-focused on social evaluation. Attention and memory are heavily biased towards detecting, magnifying, and ruminating on any potential sign of negative judgment or rejection from others. Every social situation feels like a high-stakes performance being critically reviewed.
And there's a neural basis for this too, less connection between the emotional alarm system and the regulatory frontal lobes.
That's right. Studies suggest decreased functional connectivity, or coupling, between the amygdala, the threat detector, and regions of the prefrontal cortex that normally help regulate emotional responses and put things into perspective. So, without that top-down regulation, the feeling is that social interaction is almost constantly experienced as a potential source of negative evaluation, an existential threat almost.
Okay, so pulling all this together, what does this deep dive into cognitive science actually tell us about defining mental health itself? What's the big picture?
Well, it points strongly towards the concept of integration. If you look at it through the lens of interpersonal neurobiology, optimal brain function, and thus mental health, depends on the differentiation and subsequent linkage of various neural networks and functions. So, psychopathology, from this view, can be understood as suboptimal integration. The system isn't well linked, leading to states that feel either chaotic, overwhelming, unpredictable, or rigid stuck, inflexible.
That's a really interesting way to frame illness as a lack of integration. Let's bring in Piaget here. He studied how kids build knowledge, right? And he had this idea of equilibration.
Yes, Piaget's big idea was constructivism, that knowledge isn't passively received, it's actively built through interaction with the world. And equilibration was his central criterion for intelligence. It's essentially a process of self-regulation. It's how an organism adapts and compensates for disturbances, both internal and external, to maintain stability and continue developing. Think of it as a sophisticated mental thermostat, constantly adjusting to keep you balanced and adapting effectively.
Okay. And when we think about positive mental health, it's clearly more than just not having a diagnosis. It's about having certain positive qualities like resilience, autonomy. The sources emphasize resilience and maturity.
Exactly. Maturity can be framed using models like George Vaillance's, which suggest mental health involve mastering sequential life tasks. Things like establishing intimacy, consolidating a career, developing generativity, contributing to the next generation. And absolutely central to navigating these life tasks successfully is the flexible and adaptive use of what are called mature defenses.
Right, and these aren't the defense mechanisms we usually think of in a negative way, like denial or projection. These are actually seen as adaptive strengths, almost virtues.
Precisely. They're typically unconscious or semi-conscious coping mechanisms that allow a person to handle conflict and stress gracefully without falling apart. Things like altruism, finding fulfillment in helping others, humor, the ability to face pain without being overwhelmed, finding perspective, sublimation, channeling difficult emotions into creative or productive outlets, and suppression, which is closely related to what we now call grit or resilience, the ability to consciously postpone dealing with something difficult. These mature mechanisms let you experience strong emotions and conflict flexibly.
So let's try the ultimate synthesis now. How do these early emotional experiences and schemata actually get wired into the brain physically? This brings object relations theory into the neuroscience picture.
Right, this is where it gets really integrative.
Yeah.
Those very early implicit interactions with caregivers, learning who to trust, what feels safe, what feels threatening, they don't just create psychological patterns, they actually establish stable neurobiological pathways. You can think of them as creating primordial fixed-point implicit attractor memories. These are deep, unconscious focal points in the brain's landscape that act like gravitational wells, constantly pulling the brain's ongoing self-organization back towards these early patterns.
Wow, so the brain is kind of neurologically biased to keep returning to these earliest relationship templates.
In a sense, yes. Initially, in infancy, experiences of gratification, good feelings, good caregiver, and frustration, bad feelings, bad caregiver, are often kept very separate neurologically. This is the basis of what psychoanalysts call splitting or partial object relations. And neuroscience actually supports this. The amygdala, for instance, seems to have genetically programmed pathways for segregating intensely positive and intensely negative emotional valences early on. Achieving psychological maturity, then, involves developing whole object relations. This is the capacity to see and relate to another person and oneself as a whole, someone who is complex, containing both good and bad qualities, loving and frustrating aspects, all at the same time. This requires sophisticated, higher-order cognitive synthesis. It involves moving from specific context-bound emotional episodes to more abstract, semantic understandings of people. It's about integrating the complexity, holding the contradictions. Hashtag hag outro. So if there's one critical takeaway from this whole deep dive, I think it's this. Mind development is fundamentally an embodied, relational, and self-organizing process. Our experiences, particularly those really early ones, literally sculpt our brains. They set up these foundational neural attractors and schemata that then regulate how energy and information flow through our system, profoundly influencing everything from what memories we retrieve to how we behave in relationships decades later.
And here's where it gets really provocative, I think. If our past experiences physically shape our neural circuits and create these powerful implicit attractors that guide future learning and reactions, well, how much of our future is just inevitably reinforcing those past patterns? And maybe more importantly, what kind of intentional integrative actions can we actually take to introduce a sort of beneficial disturbance, a new experience, a new insight that can help shift an old, maybe maladaptive pattern? How can we use conscious awareness to, in a sense, reprogram the implicit? Something to think about.
Thank you so much for joining us on the deep dive into the psychological sciences. We really hope this exploration has given you a clear, more integrated framework for understanding the incredible complexity of the human mind.